Hi, welcome to All About Mechanical Engineering. In today's video, we'll take a question on projection of lines in which there is a point on the given line which divides the line in a ratio. It is similar to the question which we have taken in the previous video, that is a midpoint which is given on the line. Now, let's see what's the difference. For better understanding, let's take an example. Line CMD is 100 long. CM is to MD is equals to 2 is to 3. M is located 15 above HP and on VP. The line makes an angle of 45 to HP and 30 with VP. Draw the projections of the line when the end C is in third quadrant and end D is in first quadrant. Let's extract the given data first. Line CMD, that's the name of the line. True length equals to 100 CM is to MD is equals to 2 is to 3. M is 15 above HP and on VP. Whereas C is in third quadrant, D is in first quadrant. Theta is equals to 45 and phi equals to 30 degrees. Now, as we have seen in the previous video, a midpoint divides the line in equal two parts. That's half here is MB and half is AM. Here in this question, you have C, M, and D, where CM is part X and MD is part Y. As you can see, both are not equal. So one is 2, second is 3. So CM is 2 parts and 3 parts is MD. Now you have to find the values of CM and MD in order to proceed further. In case of a midpoint question, it is easy because half of the line is in front of the given midpoint and half lies behind. Here, how to find the values in a simple manner. CM is to MD is given as 2 is to 3. Total number of parts, if you add these two, you'll get 5. The value of one part is equals to true length divided by total number of parts is equals to 100 divided by 5 comes 20 So CM is two parts, so 2 into 20 makes 40 and MD equals to 3 into 20, that is 60 So these are the values of part CM and MD. If you add these two parts, you will get the original true length, that is 100 Let's draw the solution now. Drawing the XY line, then a vertical projector. Make sure you take this vertical projector at almost the center of the XY line because some portion of the line will always fall on the back of this projector. So, in usual questions, when one end of the line is fixed, we take this projector on the extreme left. But in this case, you have to leave some space here and then take the projector taking 15 above HP and locating M dash, that's the front view of given point M, and M is given on VP, so its top view will be on XY. Now taking the angle 45 degrees as theta and drawing a line extending it backwards. Now we know MD equals to 60 so taking 60 in your compass, keeping it here on M dash, cutting an arc. Then taking 40 in your compass as CM and keeping on the same point M dash, you have to cut on another side and locating the locus. This is the locus of D in front view. Name will be D1 dash as it is the true length and corresponding locus of C in front view with the corresponding name C1 dash. As you can see, D is in first quadrant, so the front view of D is above xy because the locus of front view is above xy. Similarly, C is given in third quadrant, so its front view should be below xy, so we have the locus of C below xy. Now, taking an angle phi here with respect to M and drawing the line, extending it to on both sides, taking 60 keeping on M here, cutting in front direction here, And you have to take 40 in your compass and mark an arc on the back side. Locate the given locus of D in top view and with the name D2. Here, another corresponding locus of C in top view with the corresponding name C2. Now, for time being, forget about this much part. Now, if you start the question here, it looks very much similar to our normal question. So, the next step is project this true length from here to opposite points, opposite view. So, this is the projector, and the corresponding name will be D1. Using M as your center and MD1 as your radius, rotate it until it intersects with the locus of D in top view. You obtain the final top view point D. Similarly, you have to use this D2, project it vertically upwards to opposite points, opposite view, that is M dash. Corresponding name will be D2 dash. Using M dash as your center and M dash D2 dash as your radius, rotating it up until it intersects the locus of D in front view. The name will be D dash. That's the front view point of given D. Now simply join D dash, M dash and extend it until it meets locus of C in front view. You will get corresponding front view point of C. Similarly, you have to join D, M and extend it backwards until it meets locus of C in top view, and you will find the corresponding top view point of C. If you want to check whether you have drawn the correct solution, make your ruler parallel to this vertical projector, roll it forward. If you find a D dash and D on a single vertical line, and if you roll your ruler back and find C and C dash on a single vertical line, means you have drawn the correct solution. Hope you have enjoyed the video. See you again with another video. Thank you.